I'm going to do the last one. Find the equation of the tangent C at the point, this one. Okay. Find the possible exact value of A such that tangent cuts the y-axis at x equals to 1. Okay. At the point, okay, good. Okay. So, you know what's the question asking? No? Okay, so I'll just break down the question for you because I assume that you've already tried it at home. Each point here, this one will correspond to t equals to what? T equals to A, very good. So the parameter here is when t equals to A, find the exact value of A. Tangent with cuts, find the equation of tangent in terms of A. That's what they're trying to say. Okay. So equation of tangent, we all know. Equation of tangent. So part equation, we just do one thing at a time. So I'm just doing part 1, finding equation of tangent first. Equation of tangent. So it's y minus y1 equals to m x minus x1, right? We all know that. It's very simple. So when t equals to A, x equals to 2EA, y equals to A cubed minus A, which is not surprising because that was the point we given to us. Then dy dx is what? Is 3A squared minus 1 over 2EA. Okay, so this case here, so the equation of tangent will mean that you just replace this value inside here. This is x1, this one here. So equation of tangent will be y minus A cubed minus A equals to 3A squared minus 1 2EA x minus 2EA. All right. That's the equation of tangent. That's the equation of tangent. Oh, the answer is not given, huh? Yeah, but we're going to use the equation of tangent to find. This is the equation of tangent. You don't need to expand. You can just leave it like that. It's fine. But you want to expand also can. So I'll just actually it's very ugly. So cancel. Yeah, there. You can just leave it. I don't think need to. Wow, this is very ugly. So actually, you can just leave it here like that. It's fine. It's fine. It's fine. Yeah. Now, remember what I said is this. If you, for parametric equation, if you want to find the points, you find the parameter. You want to find the coordinates, you find a parameter. You find the equation of tangent, you find a parameter. You find the normal, you find a parameter. You find area. Everything is parameter. Everything. So when you deduce this equation here, what we are looking at is at that juncture of depending on the A, if A equals to 1, I sub inside here, then the equation of tangent will just be this. Okay. How do you visualize it? I will visualize it for you using our favorite Desmos. It's so cool, man. I love Desmos. Desmos is for the win. See this. Okay, so how does it work? It looks like that. It's very cool one. So no. Here. So you get this case here. Why is it not loaded? Because I never save. Let me load for. I'm not sure why is it not loading. Sorry, there you go. This is okay. So you see here, how it works is like that. You need to understand that this is your equation of your what do you call it? Your tangent. So with different A, right? You see that with if A is 1.2, it will just take this point here. So if you were to just take this, let me just copy this down. This is A. This is A. Okay. So we already established last week, right, that with different A value, you will actually just trace it down, right? Correct, to the on the curve here. But because our parameter is restricted from -1 to 3/2, that's why we only take part of it. But if it's from -10 to 10, it will be the different part. Okay. So this case here, if once you get the equation of tangent, what happens is with different A, you just get the equation of tangent. Yeah, so cool, right? So you just know that this will become like that. Okay. Now the next question is this. The question is find the possible exact value of A such that the tangent cuts the y-axis at number 1, right? So in other words, right, if you have okay, the best way to illustrate is using decimals, obviously, right? So you want to cut at I don't even know what the question y equals to 1. So y equals to 1 would be here. Anyone? This is y equals to 1. Anyone dispute y equals to 1 at here? No, right? So I want to find the A value which will cut y equals to 1. Oh, actually, I could find using decimals, which is A equals to 0. Easy peasy. But you can't do that in the exam. So the question now is, how do you actually find? Yeah, for that, I think that's about it, right? There's no other point here, right? Yeah, there's no other point. So you want to find, basically, if you want to illustrate on your curve, right? It looks like that. You solve it like, oh, sorry, let me just, what is this? What is this? Okay, can here you want to find the point. Let me just take a red color one. You want to find the point which cuts through here. Okay, here. So you need to find this point here. Okay, this point is very important. So what we're gonna do is essentially we're just gonna, for the last part will be sub x equals to 0 and y equals to 1 into the equation here, the equation of tangent. Okay, so that you get that ready. Once you get that, will be 1 minus a cubed. My goodness, it looks so complicated. I do not know how to deal with this, man. So this is 0. Okay, then oh, that's pretty okay because you cancel away. So we are pretty okay here. So this is 3a squared minus 1, and this would be a cubed minus 3a square plus 1. So minus 1 minus a 0. So this is 0a square minus 3a minus 1. Okay. Why do you reject the other one? That's a good question. Then I'll come back to that. So this one, just use GC. Calculate out first. So minus 3, 1 minus 3 minus 1. That's a good question actually. So from GC, you get this is 3.302 and the other one is minus 0.3027. And whereas this A here is 0. Okay, maybe actually, yeah. You always check back. So check back. They want the exact value, right? So you need to actually find, there's another point. It's a point. Okay, there's another, so you need to check. So you need to reject this one here. Okay, why? As A is minus 1, because parameter is only allowed from minus 1 to 3/2. Okay, that's why you reject. Minus 1 to 3/2. They just want to 3/2, right? So it means you need to proceed to find this exact value. So this exact value is when A goes to minus 3/2. They want exact value, right? Find the equation, possible exact values. Okay? So means I actually sort of missed another one. I'm not sure which is the one which I missed out. Is there another one which cuts through? This is 1. What else I had missed up? Oh, here, there are two. I see. Oh, very, very close. Oh, I see. Oh, you see that? Yeah, it's a scam. Sorry. Because the concavity changes. That's why there are 2 points there. Oh, interesting. Okay, it's interesting. Okay, so there's another one slightly here. But anyway, you can only see it by solving it, so it's quite cool. Yeah, I hope you can relate what you see and what you're solving. If you can solve, you can relate that way, right? It's easier for you to solve. So we need to move on with exciting life by solving this exact value. This exact value is okay, right? We know how to find it. We just use our favorite quadratic function. Yeah. Do you know that this formula here in the O level, it was given in O level A Math, MF, but not the E Math MF. So it's another scam. Do you know that? You don't know that, right? You know that this formula here, right, is given in the AMF formula. It's in O level, right? But in EMF, it's not given. It's a scam. Yeah. I don't know, man. Okay, anyway. Plus minus. 9 square minus 9 square is 13, right? 13 over 2. So I need the one which is a negative one. The positive one cannot rejected. Reject. Okay, so hence 0 and equals to 3 minus 1. Okay, yeah, that's good. Question, people, please talk to me.